Good morning. This is Unit 2, Day 2. We're going to go over our power functions today. So this is any function that can be written in the form y equals k times x to the a, where k and a are non-zero constants. That just means that they're numbers. That's not zero. Is a power function. The constant a is a power and k is the constant of proportion or constant of variation. We say that f varies as the eighth power of x, or f of x is proportional to the eighth power of x. We have these functions. I just want to go over it. We all know the circumference formula, c equals 2 pi r. The power for this formula, if there's no number, it's 1. It's like a ninja number. It's there, but we can't see it. The constant of variation is the number in front of your variable. Your variables are, my constant is going to be 2 pi. Pi is a number. It is not a variable. The area formula is a equals pi r squared. The power for the area formula is 2. Okay? And the constant of variation is a number in front of the r, which is pi. Again, we have this one's a fraction, so k is a number divided by the variable is d squared. The power is actually in the denominator. To move it to the numerator, we have to subtract it. So this is going to be -2 if we move it to the numerator, to the top. The constant of variation is a number in front of your x, or in front of your variable, which is k. And we have one more. I want you guys to try this one, Boyle's law. Writing and analyzing power functions. So in this formula, state the power and the constant of variation. Same thing, guys. T is going to be your variable, and this is going to be the constant of variation. Your power is going to be 2. You guys got this. 1/2 g. Okay. You guys can try this. It says, well, let's try it together. It says the area of an equilateral triangle equals, or it says varies directly. So varies directly means that we're going to have something multiplied, not divided. Varies directly as the square, this means it's going to be squared, of the length of the sides, of its sides. And length is s. This is my variable, s squared. And we have to say the area in terms of s, so a of s, like this. It just says say the power and constant of variation for the function, graph it, and analyze it. The power of this the graph looks like at 2, maybe it's like right here, but it's times 2, so like right here, maybe something like this. I don't know. Try it. Check it out. The power of it, if it's in a square root, this is the same as 2 to the x, 2 times x to the 1/4 square root, means we're going to have a fraction. So my power is 1/4. The constant is 2. And the domain, it looks like it's going to start right here at the origin, and it's going to go to the right. So I'm going to just analyze it. The domain looks like it's going from 0 to infinity. I can include 0, but not infinity. My range looks like it's going also from 0, and it's going to the right but up infinitely. So I'm going to say also to infinity. It looks like it's continuously increasing. It looks continuous. It doesn't look like there's any symmetry across the axes or anything like that. It's all in the first quadrant. And the absolute min is 0. Okay. Maybe you can write some of that down. A monomial is one term. It says any function that can be written as f of x equals k. This is a number. Or f of x equals k times x to the n power, where k is a constant and n is a positive integer, is called a monomial function. There are different characteristics of these monomial functions. One is if we have this function, f can be undefined. This is our first option. F can be undefined. This is something like when x is less than 0 and we have a square root, right? We can't plug in negative numbers into a square root. F could be an even function, or f could be an odd function. So if it has an even power, it's an even function. If it has an odd power, it's an odd function. Let's look at these graphs. It says the graph below represents the 4 shapes that are possible for general power functions of the form kxa. Which one is which? So I'm guessing that they want us to use something like this. Well, this one is going to be something like y equals x to the maybe something like 0.4, or something that's a decimal to the 0.4 or 1/4, something like this. Okay. Now this one, it's going to be going down. So this is going to be something like y equals x to the -3, something like that. Check it out. And I want you guys to try this one. Also, if we are looking at this red line, if it's going down, then this would be something like y equals -x to that, maybe like 1.5. Okay. Graphing the power functions. Describe how to obtain the graph of this from this parent function. It says is x to the 6. Now, if you're going to graph x to the 6 on your graphing calculator or in Desmos, it just looks like a big wide parabola, but it's not actually a parabola. It actually has turning points down here, and it might go like up, down, up. It has 5 turning points. So 1, 2, 3, 4, 5, and then it goes up like this, right? That's what it looks like, x to the 6. This is the original one. Now, if we graph -2 x to the 6, it's gonna look like something like this. I don't know, it might be a little bit more narrow, but like, I don't know, like this. 1, 2, 3, 4, 5. I don't know, maybe I did too many, sorry. Something like this. This is my transformation because it's negative. The 2 just makes it more go up quicker. It wants us to state whether the function is even or odd, sketch the graph, I did it, and support your answers with a graph. Okay, number 1, describe how to obtain this graph. What we're going to do is we're going to reflect it across the x-axis. From red to green, we're going across the x-axis because of this negative right here. Okay. The 2, that negative reflects it across the x-axis, but the 2, sorry, underline the 2 in blue, this one is a stretch vertically. Maybe I need some spaces. A little bit more space. By a factor of 2. I'll just write it out. A factor of 2. Okay. Number 3. It says, state whether the function is even or odd. Is this function even or odd? It looks like it is symmetric about the y-axis, which means my function is even. I can actually check, and I'm going to plug in a -x into my function. My original function is f of x equals -2x to the 6. I'm going to plug in a -x into that, and that's -2 parentheses -x to the 6. But since it has an even power, we're multiplying a negative number times itself an even amount of times, and that just becomes positive. So nothing's changing. This is equal to -2x to the 6. And isn't that what we had originally? if the original one is the same as when we plug in x, the signs are the same as when we plug in x, they're the exact same thing, they're equal, then it is an even function. Remember this, okay? This one, they just want us to match it. I would just graph it, guys. Plug it into Desmo. So you guys have a calculator. Use your graphing calculator. Number one, it says f of x equals, this is the fourth root of x. So the fourth root of x goes up very slowly, multiplying everything by 3. So maybe something like 16. And then we would take the fourth root of 16 and then multiply it by 3. So I would say actually that it does look like a. Maybe just grab it and make sure. Make sure I'm right, okay? Number 2 looks like we're going to flip it across the x-axis. And it looks like we're going to do something else because our exponent is negative. It doesn't look like these. Oh, it looks like we're going to have this one, right? 1 over x kind of usually has the first and third quadrant, but this one, because of the -2, it's going to look like C. So graph it and make sure. I want you guys to tell me what 3 and 4 is. Which one is B and which one's T? All right, this is the last one I'm going to try today. I think this is the last one on your paper. So it says the volume of an enclosed gas at a constant pressure varies directly as the absolute temperature. If the pressure of a 3.46 liter sample of a neon gas at 302 Kelvin, this is degrees, is 902 atm. This is pressure. 0.926 atm is pressure. What would the volume be at this temperature? Okay, well, my volume formula, I don't really know this, so this is something that they're going to give you. Volume equals constant pressure varies directly. It means we're going to multiply it and not divide it. So we have a K, we're going to multiply it by the pressure and the temperature. The pressure is, this is the pressure. We're given the pressure. We're given the Kelvin. We're given the temperature. And we're actually given the volume. So what I'm going to do is solve for K, because this is what we're going to try to find first. So in order to solve for K, I'm going to divide this right-hand side by P and T. I'm going to divide the left-hand side also by P and T. Pressure times temperature. Okay, so that means my K equals my volume over pressure times temperature. My K, my constant, I don't know, but my volume is 3.46 liters. My pressure is 0.926. And I'm going to use parentheses because then I have to multiply it also by my temperature, which my temperature is 302 Kelvin. That's very hot. I don't know. 302. That's a 3. I'll fix it. All right, I'm gonna plug this in my calculator, guys. Make sure that you have parentheses around the bottom. Make sure that this looks like this in the calculator. And we're gonna get something like Kelvin equals 0.0124. And this unit is gonna be liters divided by ATM times K, times Kelvin. All right, now they're gonna ask us something. What would the volume be? So we're asked to find the volume. I don't know the volume. V equals, at a temperature of 338 Kelvin, okay? Oh, I don't have a fraction anymore, so 338 Kelvin. I know my K. My K is 0.0124. And it says if the pressure does not change. So my pressure is going to be the same. 0.926 And we are also given, oh, the temperature is 3.38, or 338 Kelvin. Just plug it in your calculator, guys. Tell me what your new volume is. Okay. How many liters? All right, guys, this is all I'm going to do today. Have a wonderful day, and ask me if you have any questions.